Our topic is sigma notation. Sigma is used in math to indicate sum. N is the index. It indicates the number to start with. For this example, we'll start with 1. The number you plug in for n is called the input variable, and the number you get out after plugging in n is called the output result. And then you place the max value of n above the sigma. Let's use the variable k. Next to that, you have the general expression to be evaluated from n equals 1 to n equal k. It is read aloud as the sum of a sub n from n equals 1 to k, and it would look like this. And here's the first example. Let's try it. Let's do the sum of 2n minus 1 from n equals 1 to 6. Now pause the video right here to try it. Now that you've done the work and unpause the video, here's the answer. It would equal 1 plus 3 plus 5 plus 7 plus 9 plus 11. And when you add all that up, you get 36. Now you know the basics of series. Let's move on to a special kind of series. One important type is the arithmetic series. An arithmetic series is one in which each term is found by adding a constant to the preceding term. This is called the common difference. And in an arithmetic series, a sub n equals a sub 1 plus n minus 1 times the common difference. Here's an example. The sum of 1 plus 3 times n from n equals 0 to 4. Now pause the video and try to figure out that answer. Now that you've figured it out and unpause the video, this equals 1 plus 4 plus 7 plus 10 plus 13. And all that adds up to 35. You see that each number is just adding 3 to the previous term. There are two formulas to find the sum of an arithmetic series. If you know the final term in the equation, in the series, use this equation. S equals n over 2 times a sub 1 plus a sub n. If you don't know the final term, use this equation. S equals n over 2 times a sub 1 plus n minus 1 times d. Now you know all about arithmetic series. Let's go to another important type of series. This one's called a geometric series. A geometric series is one in which each term is found by multiplying the preceding term by a constant. This constant is called the common ratio. It's represented by the letter r. R equals a sub n over a sub n minus 1. That's dividing, not subtracting. You can use any term n and any term preceding that term to find the common ratio. In the geometric series, a sub n equals a times r to the n minus 1 power. Let's do an example. Let's do the sum of 3 times 2 times n to the n from 0 to 3. Pause the video to try to find out what that equals. Now that you've figured it out and unpause the video, this equals 3 plus 6 plus 12 plus 24. And all that adds up to 45. To find the sum of a geometric series, use this formula. S equals a sub 1 times r to the n minus 1 all over r minus 1. The last important thing you need to know how to do is to find the general expression for the nth term when you are given a series. This is basically just working backwards. Let's do a few examples. First, use sigma notation to represent 2 plus 4 plus 6 plus 8 for the first 45 terms. Now, you have to look at the pattern based upon the position of each term. In this problem, you're adding 2 to each previous term. This means that it's an arithmetic series and you should be able to figure out how to write that answer. Take a minute to try to figure that out. Pause the video. Now that you've unpaused the video, you know that a sub n equals 2n. And one possible answer, although there are a couple, is the sum of 2n from n equals 1 to 45. Perfect. Let's try it again. Use sigma notation to represent -3 plus 6 minus 9 plus 12 minus 15 for the first 50 terms. Pause the video to try to figure that out. Now that you've unpaused the video, you should have figured out that one possible answer is the sum of -1 to the n power times 3n from n equals 1 to 50. Whenever you have an alternating series like this that goes negative, positive, you'll know that you'll have to use -1 to the n power. If you use -1 to the n power, then the first term of the series will be negative, as shown here. If you use -1 to the n minus 1 power, then the series would start with a positive and the second term would be negative. Now you know all you have to know about summation notation, and you should ace calculus next year when this topic comes up. This presentation was brought to you by Emily Portuguese and Jisoo Yoon. Thanks for watching.